Good morning. I hope you all got safely to Barcelona. I myself arrived a little bit late due to the flight situation, kind of complicated these days. I want to welcome you here to the summit, and I want to talk about projects from the past and the present, not any futuristic projects, which we'll hear mainly about in the next 2 days. So in this case, we'll have all ages covered. I'll talk about the past, present, and then we'll talk jointly about the future. So my presentation is on adaptive architecture. What is adaptive architecture? Adaptive architecture has a long history, and it goes back to the oldest man-made form of architecture. Here's the first example that you can see. It's a mobile bridge constructed by boats from the Persian army marching into Greece. That was around 480 BC. Another type of mobile architecture, of adaptive architecture, can be found with the nomadic tribes. This dates back to over 4000 BC. We have the Mongolians, the Red Indians, or even the Arabian Bedouins who lived in tents, and these tents could be erected and dismantled in just a few hours to travel wherever they can find water and food. Once packed together, these structures were put on animals and then carried throughout the country. This means, or this implies, that these mobile structures had to be of lightest weight. Therefore, materials had to be chosen very carefully, not only for being able to pack them together and transport them, but of course also to shelter and protect from sun and rain, but also big temperature changes. Going into the materials, I want to talk a little bit about today's material usage in adaptive architecture. Also today, one of the governing facts is the right materials. Here you can see the process of a carbon composite structure being put together. First, you have the carbon fibers, which are weaved together to large sheets, and then they're treated with resin and put together, put into a mold. Within the mold, there is a foam core put inside, and then the whole composition is put in a big oven, an autoclave, in order to cure them and then transform these materials into an ultra-lightweight, high-strength, and very efficient building part. In this case, you can see down here in the picture on the bottom right that the composite material was finished then with ceramic tiles. This gives them the required protection from UV light. Obviously, this is not the standard building material. So, where did this technology come from? Where did it originate? Commonly, this technology is used in boats and car industry, and we've introduced this the first time into our work with the sliding domes in Medina. The 27 domes had to be of lightest weight to achieve the client's wish of having a natural environment inside the courtyards. So these are covering 27 courtyards, and the idea of the client was that he has a climate like under palm trees. However, under palm trees or plants and trees, they, through photosynthesis, create kind of a natural air conditioning. The exchange between oxygen and CO2 keeps temperatures below 30 degrees. Obviously, we're not able to create something like that with our man-made structures, but we can get quite close with adaptive architecture. Here you can see how the courtyards are opened, the sliding domes are driving on the side, and this exposes then the inner courtyard to the sky. In the morning hours, once the sun comes out, then you can heat up and warm up the building and capture all the energy, and then towards the night, you can close it again. This is in winter time, you can close it again and keep the energy inside the courtyards. In summer, you do it vice versa. You open it at night, so all the energy goes out and cools off towards the cold night sky. and during daytime, as you can see here, you leave it open to capture all the energy. What other concepts can be seen in the kingdom on the subject of mobile structures, of adaptive architecture? One big example is the Munaten city. The Munaten city is a complete city built as a convertible system. Once a year, the whole valley is filled with around about 2 million, 2.5 million pilgrims coming from all over the world and gathering for the Hajj. And therefore the city is transformed from a ghost-like city to this huge gathering with 2.5 million people who of course live there for a few days, and therefore it's like a mobile, it's like an adaptive system accommodating once a year all these people. The good thing about these tent structures is that in the off-season you can take off the walls, you can take off the roof, take off all the flooring and everything, and therefore you have a very lightweight steel structure, very efficient and lightweight steel structure, as it's not exposed to severe weather conditions. There is no surfaces that can be exposed to strong winds or rains or any of that. Therefore, we keep the steel structure very light. In addition, for this special project, there was the requirement to find a material which is non-combustible, as these tents are standing very close to each other, and pilgrims like to cook their food and whatever, so they have open fires, which was a big challenge at the time. We found material called Ptfe. This I'll come a little bit later and talk about the Ptfe material. Just a few weeks before all the pilgrims arrive, you can see it here as they're arriving in buses and then walking through this tent city. All the floors and walls and everything is put back in, the air conditioning is equipped, and all the infrastructure is being put in place. At the time when we designed this project, when we designed these fire-rated tents, we made a concept for all infrastructural elements, the water supply, toilets, and ablution areas, all were done in the same concept of having mobile structures. Unfortunately, this was not constructed like that. Our intent in the day was that we keep a high level of hygiene, since all these mobile structures could be removed, cleaned elaborately, and also you minimize the impact on the valley itself. There is no heavy foundations, there is no heavy ductwork and heavy infrastructural undertaking to install such kind of structures. So coming back to Ptfe material, this material is originally known in the filtration industry. We have, in the search of finding a non-combustible material, we've come across this and made several tests, and well, actually a long cycle of testing, seeing if it's really non-combustible and if it's usable in architecture. The material itself is very interesting because it has all properties for protecting the people. It stays elastic, it doesn't get brittle, and of course it can sustain these high UV lights that are the subject in the desert of Saudi Arabia. This brings me to the last project I want to present to you today, the Medina Piazza Shading. This is an outstanding marvel of adaptive architecture. The Piazza Shading is a convertible roof structure, which you can see here, built around the Holy Mosque in Mecca, with 250 umbrella structures which are overlapping and therefore give a combined roof of 150,000 square meters. The interesting thing here is the beauty of adaptive architecture becomes evident once we look at this project. Here, if the space is not needed, you fold away the umbrellas and you open up the space to the public, and everyone can walk and wander around. If you have the requirement of adding more space to the mosque, you can unfold partially the piazza umbrellas or the entire piazza umbrellas according to the needs that you have. This we can also see in the next slides. Here you can see that a part of the umbrellas opened, and then on the top and bottom picture on the right side you can see the closed umbrellas. compared to a built structure, this is very efficient, because a built structure, which is used in only once a year for this massive amount of people, becomes highly inefficient. We have construction costs, we have heavy foundations, we have operation maintenance costs, we have all the resources required to keep such a constructed building up and running. For these adaptive structures, this is obviously not the case. Once the umbrellas are closed, the whole project can be shut down and put at rest, and then when needed, you unfold it and open it again. Another good factor about these adaptive structures is that you still maintain a visibility to the sky and the cityscape around, so it's not an enclosed room. You always feel the space around you, which helps. It's a big enhancement on the people in terms of claustrophobic experiences, which generally is a problem in large venues. I'll speed up because the time is running out, as I just saw. And I just want to show you this picture. This is in the middle of opening and closing. Just to show you, this also gives a very aesthetic view throughout the whole process. And finally, the last slide I want to show you is a video showing this opening sequence. This here, before the second last, is giving you a character of this market, city square feeling that can be created through these structures. Could you please run the video? I can do it from here. You just slide over it. You have to slide over it, and then there's a... Das soll der Delay kommen. Seems not to be working, sorry for that. I actually wanted to show you the closing sequence. This is in Ramadan in Medina, when the sun is coming down and all the people become more lively, they've eaten, they've drank, the umbrellas come down, and then the square really becomes to life. So it's actually nice to see. Anyhow, maybe next time. Thank you.